This and run. So chapter 9 is very different than factoring. Forgive me if I'm wrong. We do have one section on factoring as we get partway through. But with this, we're kind of turning a corner. I think most of you will find this to be quite a bit easier. But it's still working with quadratic. So a quadratic is an equation that can be written in the form of y equals, and I might need to squeeze a little bit, ax squared plus bx plus c. And the x is just going to be a variable, same with the y, but the a, the b, and the c are just going to be numbers. So like y equals 5x squared plus 7x plus 2. Or maybe you could have a minus sign in there. But the key is you have to have this part right there. So and a does not equal 0. So a quadratic could be something like y equals 3x squared plus 2x, and I'll put in like a minus 5. So c then technically, because we have this plus c over here, c technically in that case is a negative 5. Is that fair? Okay. You could also, you don't need to have all those parts. You could just have y equals negative 1.5x squared. That also would work as a quadratic. But you can't skip that first term. So I'm going to write this. I don't know if I'd write it yet, but you can't have like a y equals 2x plus 7. You know, that's not a quadratic. You have to have something in front of an x squared. But you could say like a y equals 2x squared plus 7. That's a quadratic. We okay on those? And we're going to, this first section is really just looking at like what are quadratics, what do they look like for graphs, what do they look like in data tables and some of that type of stuff. So the next one then, I'm okay to jump down to graphs. So equations will be those. So the question then is, if we have an equation like that, what is the graph going to look like? And the graphs will always have, I'm going to say, one curve. And that's not really a scientific or even maybe mathematical definition, but if you try to do something like this here, my drawing leaves a little bit to be desired, but it turns once. It could open up like that, or it could open downward. Ooh, I'm going to back up. I'm going to try to do one kind of skinny one and one kind of like super wide. So it's not really the width of it as much as it has one curve and it either opens up or it opens down. Fair enough? So I'm going to put between those a little or. And I'm going to put a dot at the bottom of the curve. And it should be symmetrical if I did it right. The left side from that red dot should look the same as the right side. So my drawings aren't perfect, but they're not terrible. But those two red dots are each individually, they're called a vertex. So the highest point at that one on the right or the lowest point at the one on the left are both going to be a vertex. The plural for that would be vertices, but I just wrote the singular. So each one is a vertex. Fair enough? So that's what the graphs look like. Now the data table, so if we wanted to take one of those graphs and take all those points along there, so this point, this point, this point, this point, and put them in a data table. For the data table, or for a data table to be a quadratic, when x has a constant difference is like what you find by subtracting the numbers, right? So each of these is going up by 3. 3 minus 0 is 3. 6 minus 3 is 3. So when the x has a constant difference, and in my notes I wrote like a plus 3, plus 3, plus 3. You'll notice the y values don't. Going from a 7 to a 19, that's a plus 12. From 19 to 67 is a plus 40 something, right? Who's feeling smart? 48. Okay, cool. And 67 to 151 is going to be a plus 51 plus 33, 84. So the difference in the y's isn't the same, agreed? But if we were to do that one more time, from 12 to 48 is going up 36. From 48 to 84 is going up 36. Wow. So, and that kind of ties into that x squared, that it has to have that x squared. But y will have a constant, they call it second difference. So I'm going to do a 2md second difference. And if I were to get really excited, if I remembered calculus better, this is going to tie into calculus. sort of stuff. That first class you'll take in college, or the one you'll take like AP Calculus maybe senior year or something like that. And it's really cool, but it's not easy. So, okay, moving on. But what you can do with calculus is really sweet. Okay, graphs. So if we're looking at graphs, I probably should have charged up all the calculators. We'll assume that most of them work. But put data table points on the graph. So you could take, the easiest by far is to take that, pop it into a graphing calculator, and just do the table thing, and then put points on. That totally works. That's going to be legit. I'm assuming that by now you guys would be good. You could put in a number for x, find y, put the point on the graph. Put a different number in for x, find y, put the point on the graph. So if we were to take this one here, y equals 2x squared plus 1. Maybe we'll just try to do this quickly. So if I put in a 0, so if I put 0 in there, I'm going to get a 1. And so I'm going to get a 1. If I put a 1 in for x, so I put a 1. 1 squared is 1 times 2 is 2 plus 1 gives me a 3. And maybe I'll put in like a 3. So 3, I'll put in a 2. Otherwise I'm going to be really big. Okay, so 2 squared is 4 times 2 is 8 plus 1 is 9. All right, so if I would take and put those points on, I'm going to say my y values need to go up to 10. So maybe I'll put a 10 up here, put a 5 in the middle, and that's going to be my origin kind of down there. My x values, I'm going to go up to 2. So I'll put a 2 over there, and I have a 1. All right, now we can kind of estimate our points. So over 0, up 1. Does that look believable? Maybe a little low. Then over 1, up 3. So that'd be something like that. A little over halfway to 5. And then over 2, up 9, so a little below my 10. Now, if I punch it into my calculator correctly, if I have 1 squared, do you agree that's going to be the same as negative 1 squared? So if I have 1 giving me 3, negative 1 should also have a height of 3. So you could go back here to go left 1. So it should be symmetrical about the origin. Until we start doing crazy things with parentheses, like a x minus 2, quantity squared, stuff like that. Until we start doing things like that with our x values, it's going to be symmetrical. So over here at negative 2, I'm going to also be up 9. So once you find 1/2 of your graph, you can just go back and kind of fill in the other side. Now, the goal is to try to make kind of a smooth curve through those points. You don't want to do like straight lines, segments going from point to point, but try to do a curve, something like that. Good? When I'm looking at graphs, usually I try to look for, if it's on graph paper, are you hitting like the coordinates there correctly? Often I'll look at what happens here and here. I'd encourage you not to go too far past your last dot. I've graded a lot of graphs that they do really well up to there, and then they go kind of like, out to the side. And then I mark them down because, they shouldn't have crossed, that next grid line on their graph. So find some points, draw it really well by those points, but don't go crazy outside of that. Work for you? Then what's the last thing I want to say? Okay, so the vertex. The vertex is going to be, in that picture before, that spot right there on this one. It'll either be the lowest point or it'll be the highest point if it opens down, if we would flip that one upside down. So vertex, I'm going to write equals the maximum. And throw in parentheses the highest, or the minimum, which is the lowest y value. So either be the smallest y value or the biggest y value. So a couple days ago was spring break, and on spring break, unless you were riding in the car with your family, you probably looked like this, yes? Okay, brag, you get to fly. I'm just jealous. Okay, so people that smile a lot tend to be happy. Positive or negative? So a is positive. So if the number in front of the x squared, because a is that x squared coefficient, number in front of x squared, if it's positive, it's going to open up like the smiley face, yes? Negative people, or your family, if you've been in the car for 12 hours, a is negative. Those people, it's like a parabola that opens downward. So if you ever have like a negative 7x squared, it's going to be a parabola like that second one. All right, ready for the very last thing?
Yeah.
Cool. Let's get it done then. Okay, so then domain and range. Domain, is that all the x or all the y's?
X.
X, nice, because x comes before y, d comes before r. So domain is going to be all the possible x values. Maybe I should write it this way. So all possible x values. If we think back to the equation, you could look at this a couple ways. Either look at the graphs or look at the equations. But if you have like y equals 5x squared plus 2x minus 9, is there any number we couldn't put in for x and find a y? You could do positives, you could do negatives, you could put in a 0, you could do a decimal. So when you have these quadratics, or parabolas, we're going to call them later on in life, the domain is going to be all real numbers. The other way to look at it is if you have a graph like this one here, if it keeps going in this direction, keeps going in that direction, do you agree eventually it's going to be way, way, way off to the, I should probably be looking at a graph. My graph here, eventually if this keeps going like here, it's going to get out to 1 million over there some ways. It's just going to be up really, 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 really crazy high, right? But it keeps going off to the right, keeps going off to the left. So x is going to be all real numbers. The y value, though, the range, so range we could say is all possible y values. Now our graphs, they have a certain endpoint that, if I go up to this graph because it's nicer, this here, this vertex, this y value, is the lowest possible y value. It doesn't get any lower than that, but it goes up to infinity, agreed? A graph like this would have a vertex right there. That's going to be the highest y value right there. But it keeps going down, keeps getting negative to like negative infinity. Agreed? So what do we want to write here? So I'm going to write something like r colon for the range. Y is greater than or equal to 1. And that would fit that nicer graph we did up above, that the smallest y value is 1. But you have all the y values that are bigger than 1 or equal to 1. If you were to have one, something like this graph here, if you knew that height maybe was like a 7, then it'd be y is less than or equal to 7. Work for you? So ranges will always have that type of format. Domain will always be all real numbers. So, and you could, for this one, do a d colon if you wanted to. But that's it for this section. Is that all right? Sure.